Yeah, good afternoon, students. As I said yesterday itself, as I said yesterday, those who failed or those who got less marks, very less marks, and if you want to improve, only 3 chapters you are going to take care of. Circles, 22 marks. Parabola, 9 marks. System of circles, 6 marks. And integrations, that is indefinite. Indefinite integration, 18 marks. Is it clear? Here 2 long answers will be covered. Here 1 long answer. Here 2 long answers. So total 5 long answers it will be covered here itself. So what I am suggesting you is these 3-4 chapters you concentrate more, because these are long answers chapters. You have to do it compulsory. Here very less number of long answers and 4 mark also. 1 4 here, 1 4 here. 2 4 marks will be covered. And 1 more 4 you can do from hyperbola, which has been done. And 1 more 4, I am going to teach you now linear differential equations. 4 marks, variable separable as well as linear. Everything will mix up. And these are your 2 4-mark questions, which you are going to do. And definite integrals also, areas problems, now you don't touch it. That very important questions already I taught you in definite integrals. 0 to pi by 4, log of 1 plus x by 1 plus x square, sin x minus cos x by 16 plus 9 sin 2x, like that. These questions already has been done. Almost all those questions I finished, so that you can go through those questions also. Is it clear? But your target should be 2 circles, 2 indefinite integration, and 1 from parabola, right? So again, standard equation of the parabola, it was asked last year only. So here you go for area of a triangle formed by the points on the parabola, that is 1 by 8a problem. So your parabola long answers are also has been done the other day, right? Now, let us go for some differential equations, short answers. Is it clear? Easily you can do it, this also. First one, solve dy by dx is e power x minus y plus x square e power minus y. Usually your 4 mark what is given is, linear form of the differential equation. For every time it need not be really linear. Okay, yeah, 1 minute. Yeah, most of the times is giving linear form of a differential equation only, right? So, but sometimes other things can be asked. So let us do variable separable 1, linear differential equations, linear form of a differential equation also I will do. Is it clear? So let us see these things. Now here dy by dx, this is not in the form of linear differential equation. In yesterday class, I told you what is linear form of a differential equation. That is dy by dx plus p of x into y equal to q of x. Then you will come across one, what we say. Then you will come across one integrating factor, correct? Right. So dy by dx is equal to this. I am going to write it as e power x, e power minus y, x square and e power minus y. So dy by dx is equal to e power minus y, e power x plus x square. Take e power y common. Now variables are separated. Variable separable method, right? Means all y terms to one place. That is 1 by e power y dy, and this is e power x plus x square, and this is dx. Now integrate on both sides. That is integration of 1 by e power minus y. You bring it to numerator, it becomes e power plus y dy equal to integration of e power x plus x square dx. Integration of e power y is e power y. Integration of e power x is e power x. Integration of x square is x cube by 3 plus c. So this is your answer. Is it clear? Next. Dy by dx is equal to, the question is, dy by dx is equal to xy plus y divided by xy plus x. Now dy by dx equal to, here you are going to take y common x plus 1, x common y plus 1. Now again, variables are separated. Variables are separated. It means y plus 1 will come to numerator. See, y plus 1 comes to numerator, y comes to denominator, dy. Now this will be as it is, and dx means dy to one side, dx to another side, and dy means I should have all y variables, dx means I should have all x variables. Now integrate on both sides. That is integration of y plus 1 by y dy is equal to integration of x plus 1 by x dx. Now integration of y gets cancelled. This is 1 by y dy. X separate your x for both numerator. X by x is 1 plus 1 by x dx. Now integration of 1 is y. Integration of 1 by y is log y. Integration of 1 is x. Integration of 1 by x is log x plus c. So this is your complete final answer, or you can make some simplifications also. That is log c, you write it as log c. C you write it as log c, means y minus x is equal to, that is log x minus log y, log x minus log y plus log c. Then y minus x is equal to log of xc by y. According to logarithmic properties, log x plus log c is log xc, and minus log y means that comes in denominator to the base e. So e to the power y by x equal to xc by y. So this is your complete simplification of your answer. Is it clear? Okay, next. Solve y minus x dy by dx. Y minus x dy by dx is equal to 5 into y square plus dy by dx. Y minus x dy by dx is equal to 5 into y square plus dy by dx. Okay. Now solution y minus x dy by dx. Multiply 5 inside. 5y square 5 dy by dx. That is y minus 5y square equal to 5 plus x common dy by dx. Again, variables are separated. Variables are separated means here dy and dx cannot be in denominator. Okay. So bring this y minus 5y square to that side and dx to this side, and 5 plus x, that is 1 by 5 plus x dx. That is 1 by y minus 5y square dy. Now integrate on both sides. Integrate on both sides. What I'm going to get? Integration of 1 by 5 plus x dx. Integration of 1 by y minus 5y square dy. 5y square dy. Okay. Now see here. This is anyway log of 5 plus x, because the derivative of denominator 5 plus x derivative is 1, which is in numerator, equal to 1 by y common 1 minus 5y dy. This you are going to do partial fractions, but I am going to do little bit directly. How that works means here it is y 1 minus 5y, correct? Now take LCM. 1 minus 5y, if I take LCM, I get here. Y I will get here, suppose. But in order to cancel y and y, I want 5 and minus. Sorry, plus. Is it clear? Right. So same thing. After I write, you can have a look. Integration of y and 1 minus 5y. So 1 here 5, and you put plus in between them. Sir, I can't do this one directly. Then you take it partial fraction separately. In what way? Have a look. Your partial fractions. 1 by y into 1 minus 5y is a by y plus by 1 minus 5y. Right? Now you don't know how to do partial fractions in your 2a. Right, same. So if you want, you check it here. You cross multiply, you will get the same thing. 1 minus 5y plus 5y by y into 1 minus 5y. See, y gets cancelled. Is I'm getting the same previous step back or not? That's all. Okay. Right. Now log of 5 plus x equal to integration of 1 by y dy. Right. Now see integration of 5 by 1 minus 5y dy. Separate your integration. So log of 5 plus x is equal to, this is log y. Here derivative of denominator 1 minus 5y, derivative of denominator 1 minus 5y, the derivative of denominator 1 minus 5y is minus 5, but I'm having plus 5. So put 1 minus outside and minus 5 by 1 minus 5y. Is it clear? That is nothing but it's dy. Now log of 5 plus x. This is log y. Now the derivative of denominator is present in numerator. 1 minus 5y. 1 minus 5y. Since everything is in log, we take it as log c. Is it clear? Now bring all the terms to one side. Your wish, whichever the way you want, but cancel log. So bring minus part and this to this side. So what I'm going to get that? Okay, you do one thing. Log yc by 1 minus 5y, correct? According to log definition, y into c by 1 minus 5y. So that is log of 5 plus x is equal to log of, whenever I'm having plus, here I'm having plus, here I'm having plus, here plus, here plus, yc, that comes in yc by 1 minus 5y. Now both sides log gets cancelled. 5 plus x equal to yc by 1 minus 5y. Then yc equal to 5 plus x into 1 minus 5y. This is your complete simplification. Is it clear? So, yeah, 4 marks. We can ask anything. Next. So, very important sum. This is also. First, bring all x dy by dx terms to one side, non-dy by dx terms to another side. Then, like this, non-dy by dx terms and dy by dx terms. Now, variables are separated, right? Variables are separated means 1 by 5 plus x dx and this. And here, you are going to do partial fractions. If you are unable to do partial fractions directly in rough or side by, you can go for these are two linear factors. Is it clear? Right. Solve xy square plus x into dx plus yx square plus y dy equal to 0. Again, first get into the form of dy by dx. So bring dx to that side. So yx square plus y dy minus xy square plus x dx. Take y common, x square plus 1 dy. Take x common, y square plus 1 dx minus. See here, all x variables and y terms, I got either in product or division. Then only I can separate them, right? Now dy is there this side. Bring all y terms to this side. So y by y square plus 1 dy and minus x by x square plus 1 dx. See, first get all x variables or y variables to either side, and dy and dx should be in numerator. Now integrate on both sides. That is integration of y by y square plus 1 dy minus outside x by x square plus 1 dx. Now multiply and divide with 2 so that the derivative of denominator present in numerator minus 1 by 2, 2x by 1 plus x square dx. Now half as it is log of y square plus 1 minus half as it is. Since everything is in log, you are going to take constant c as log c. Constant also you are going to take it as log c. Now half. Bring this half inside. Half log y square plus 1 plus half log 1 plus x square equal to log c. Take 2 LCM and bring it to that side. Log y square plus 1 plus log 1 plus x square equal to 2 log c. Now this is log of y square plus 1. Log m plus log n. Already I told you log m plus log n is log mn. Okay. Into this is 1 plus x square equal to log c square. Yeah, log c square is again one more constant. Y square plus 1 plus x square log, let it be one more constant c. So both sides log gets cancelled. Your ultimate answer is 1 plus x square into 1 plus y square equal to c. This is your answer. Is it clear, everybody? Okay, next one. Solve dy by dx equal to y square plus 2y by x minus 1. Same. Variables are separated directly here. Variables are separated. That is 1 by y square plus 2y dy. 1 by x minus 1 dx. Now 1 by y common, y plus 2 dy. 1 by x minus 1 dx. Now integrate on both sides. Integration of 1 by x minus 1 dx. Now integration of 1 by y into y plus 2, again partial fractions. I am doing directly. This is y and y plus 2. Take LCM, minus 1 and 1. But what is happening? Extra 2 I am getting, correct? No? Take LCM, y plus 2 minus y by y into y plus 2. So that's why, since I'm getting extra 2, here we are going to multiply and divide with 1 by 2 outside. Okay. Sir, we are unable to do directly. See here, 1 by y into y plus 2. That is a by y plus b by y plus 2. That is 1 equal to a into y plus 2 plus by. Now do partial fractions. You'll get your required answer. Is it clear? Right. dy equal to integration of 1 by x minus 1 dx. Okay. So 1 by 2. Integration of 1 by y is log y minus log y plus 2 is equal to log x minus 1 plus log c. If everything is in log, take log c, right? That is half log of log m minus log n. Log m by n is equal to log mn. Bring 2 to that side. Log y by y plus 2. 2 log of x minus 1 into c. That is log of y by y plus 2. Log x minus 1 whole square into, actually you get c square. Again c square you take it as one more constant, let it be c. Now both sides log gets cancelled. So y by y plus 2 equal to x minus 1 whole square c. Means y is equal to y plus 2 into x minus 1 whole square. This is your complete simplification. Is it clear, everybody? Okay. Solve sine inverse of dy by dx is equal to x plus y. Solve sine inverse of dy by dx is equal to x plus y. Solve sine inverse of dy by dx is equal to x plus y. Now make dy by dx subject. That's sine of x plus y. Now here I can't do variable separable directly, because sine of x plus y, if you expand it, what I will get is sine x cos y plus cos x sine y, which I can't do variable separable. Is it clear? And it is not going to any other methods also, like homogeneous or non-homogeneous or linear form of a differential equation. So for that, what I am going to do is put x plus y equal to t. Differentiate with respect to x. This is one kind of way of doing. 1 plus y derivative is dy by dx. This is dt by dx. Now you make dy by dx subject. That is dt by dx minus 1. Now come and replace everything here. dy by dx, here you are going to replace. That is dt by dx minus 1 is equal to sine x plus y is nothing but t. Sine x plus y is nothing but t. Means dt by dx equal to 1 plus sine t. Now variables are separated. Now variables are separated. That is 1 by 1 plus sine t dt. This whole thing, you bring it to denominator and dx to that side. Now integrate on both sides. Integration of 1 by 1 plus sine t dt and integration of 1 dx. Now, integration of 1 by 1 plus sine t, what I am going to do? Rationalize. That is 1 minus sine t by 1 plus sine t into 1 minus sine t dt is equal to integration of 1 dx. Now, integration of 1 minus sine t by 1 minus sine square t dt. Integration of 1 dx. So integration of 1 minus sine t by 1 minus sine square is cos square t dt. Integration of 1 dx. That is integration of integration of, now okay, let us do in next integration. So what I got? Integration of 1 minus sine t by cos square t and integration of 1 dx. Now 1 by cos square t is secant square t. Sine by 1 cos is tan t and one more cos is 1 by cos is secant t dt. Integration of 1 dx. Now integration of secant square t is tan t minus integration of secant x tan x is secant x is equal to x plus c secant t. But what is t we considered? Tan of x plus y minus secant of x plus y equal to x plus c. That is your final answer. Is it clear? This also, you have a look. Solve dy by dx minus x tan of y minus x equal to 1. Same approach again. See, x into tan of y minus x, I can't do variable separable. So what I'm going to do? Put y minus x is equal to t. Then differentiate with respect to x. Y derivative, what I'm going to get? Dy by dx minus 1 equal to dt by dx. Now dy by dx is equal to dt by dx plus 1. Dy by dx is equal to dt by dx plus 1. Now, what is dy by dx? Replace it. That is dt by dx plus 1 is your dy by dx. Now, minus 1 as dt minus x tan t is equal to 1. Now, 1 and 1 gets cancelled on both sides. Now, dy by, now dt by dx equal to x tan t. 1 both sides it gets cancelled, the other side it becomes 0. Now variables are separated like this. The variables are separated. But I'm going to get 1 by tan t dt and x dx. Now 1 by tan t, what I can write? 1 by tan is nothing but cot t dt and integration of x dx. Integration of cot t dt. What is integration of cot? Integration of cot is log of cos by sine, no? Right? So log mod sine t equal to x square by 2 plus c. That is log mod sine t means what? Y minus x equal to x square. Integration of x is nothing but x square by 2 plus c. Is it clear, everybody? So these are the important questions that you have to know it. Next, these are your variable separable method based by substituting x plus y equal to t or y minus x equal to t, all these things. Very, very important this is. Solve 1 plus y square dx tan inverse y minus x dy. Okay, whether it is variable superbola, homogeneous, non-homogeneous, or linear form, nothing he will say. Only he will say solve. Whatever the form is given, write first in the form of dy by dx. So your dy by dx is 1 plus y square by tan inverse y minus x. Again, you cross multiply, you get the same thing. Is it clear? And now, this is not homogeneous. Here I can't do variable separable also because 1 tan inverse y minus x. See, variable separable is possible in between x and y if I'm having product, or x by y, like this only. If I'm having x plus y, x minus y, I can't do variable separable there. Is it clear? That's why in your previous sums, wherever I can't do variable separable because of x minus y and x plus y, that's why we took it as equal to t. But here t is also not possible. Okay, so that's why dy by dx. This is not homogeneous also. Homogeneous means what I said in yesterday's class, each and every term degree should be 2. I mean equal. In this case, constant is there. Non-homogeneous also not possible. In non-homogeneous, degree should be 1. There should be linear equations. So here I'm having square. Definitely, it should go in the form of linear, reciprocal it. That is tan inverse minus x by 1 plus y square. Now dx by dy equal to tan inverse y by 1 plus y square minus x by 1 plus y square. You reciprocal the given differential equation as dx by dy, tan inverse y. Yeah, in linear form, 2 cases I said. What are they? Linear form of a differential equation. dy by dx plus p of x into y equal to q of x. There are integrating factor e to the power p of x dx. And solution y into integrating factor q of x into integrating factor. Already I told you this part. What is another one? Dx by dy plus it should be q of y into x, and it should, okay, we take this as p of y and this is q of y. Is it clear? Now your integrating factor will be p of y dy, and solution will be x into integrating factor and integration of q of y integrating factor. Already I told you in last class only. Already I told you this one in your last class itself. So that's why I did reciprocal now. Here it was not possible to do into linear form of that. So that's why I did reciprocal. Then I separated it. Now bring this term inside here. Is it clear? That is dx by dy plus x by 1 plus y square equal to tan inverse y by 1 plus y square. See, is it in this form? Check it. X power 1. So here, this is in the form of, dx by dy plus p of y into x equal to q of y. So here your p of y is 1 by 1 plus y square. Your q of y tan inverse y by 1 plus y square. Your p of y 1 by 1 plus y square. Your q of y tan inverse y by 1 plus y square. Is it clear? Now let us do integrating factor. Your integrating factor, that is e to the power integration of p of y dy. E to the power integration of, what is your p of y? Go for your previous board. Your p of y is this 1 by 1 plus y square. So that is 1 by 1 plus y square dy. E to the power, this is tan inverse of y. Now solution. I got integrating factor x into integrating factor q of y into integrating factor dy plus c. X into e to the power tan inverse y equal to what was your q of y? Q of y tan inverse y by 1 plus tan inverse y, tan inverse y by 1 plus y square, again e to the power tan inverse y dy plus c. Now this is okay. Here put tan inverse y equal to t. When I do differentiate with respect to y, right? So tan inverse y is 1 by 1 plus y square dy equal to dt. Now that becomes x e power tan inverse y, that is equal to tan inverse y is nothing but t. This is also e power t by this 1 by 1 plus y square dy. It becomes what? Dt. Now x e power tan inverse y equal to start integration. That is integration by parts. Integration by parts you are going to do here. Is it clear? T into integration of e power t is t minus t derivative and integration of e power t dt. X e power tan inverse y equal to t e power t t e power t minus derivative of t is 1, integration of e power t is complete, e power t again plus c. Now x e power tan inverse y, e power tan inverse y into tan inverse y minus 1 plus c. I'm taking e power t common, and what is t we considered? What is t we considered? E power tan inverse y. So this is your perfect complete answer, and this is very, very important for 2 mark, and so many times he asked also. Is it clear? Yeah, let us do one more. Next, solve dy by dx plus 2y by x equal to 2x square. Now this is in the form of, see, this is in the form of dy by dx plus p of x into y equal to q of x. Is it clear? Right. So here, what is your p of x? 2 by x. What is your q of x? 2x squared. Correct now? Now integrating factor. E to the power integration of p of x dx. E to the power integration of 2 by x dx. That is e to the power right to outside integration of 1 by x dx. That is e to the power 2 into log x. Correct? No, to the base e. So that is e to the power log x square to the base e. According to logarithmic properties, this 2 will come as the power of x. Now e to the power log f of x to the base e, which is nothing but your f of x as it is. In this case, your f of this is your integrating factor. Now solution, what it goes? Your solution is y into integrating factor is equal to q of x into integrating factor dx. Here it is first method of your linear form of a differential equation. So y into integrating factor is x square. Now what is q of x? 2x square. Again x square into dx plus c. That is yx square, 2 outside, x power 4 dx plus c. Yx square equal to 2 into x power 5 by 5 plus c. So that is your complete simplification of your answer. Is it clear, everybody? Right. Or linear form, what we are discussing is one more. Solve 1 plus x square dy by dx plus 2x square by 1 plus x square minus 4x square equal to 0. In the linear form of dy by dx, always dy by dx coefficient, it should be 1. So here 1 plus x square dy by dx plus, sorry, this is not there. Your question is 2xy, 1 plus x square dy by dx plus 2xy minus 4x square equal to 0. 1 plus x square dy by dx plus 2xy equal to bring 4x square to that side. Now dy by dx coefficient I want to make it 1, means divide with 1 plus x square 4x square by 1 plus x square. Now this is in the form of dy by dx plus p of x into y, see y power 1 only, equal to q of x. So here your p of x is 2x by 1 plus x square. Your q of x is 4x square by 1 plus x square. Okay. Now integrating factor. Integrating factor e to the power p of x dx. E to the power integration of what is p of x? 2x by 1 plus x square dx. E to the power, now derivative of denominator is present in numerator. Log of 1 plus x square dx. It's nothing but 1 plus x square. Just now I said e to the power log f of x to the base e. Now solution, y into integrating factor q of y into integrating factor dx plus c. So y into it is 1 plus x square. And what is your q of y? 4x square by 1 plus x square into what is your integrating factor? 1 plus x square dx plus c. Now these two gets cancelled. So y into 1 plus x square equal to, write for it outside, integration of x square dx is x cube by 3 plus c. So this is your final answer, and this is also important for 4 mark. Okay. So if you want, you can take 3 common, but for these things, you won't get any marks less, right? So, and tomorrow also we'll do more differential equation 4 mark, so that you can compulsory attempt 4 mark differential equation 1, circles 2, 1 4 mark differential equation, system of circles 1, 3, right? And ellipse and hyperbola, there you get total 3 short answers, which already hyperbola is done. So you can choose from there. But in order to get your marks, you should be careful with your long answers. Is it clear? The long answers, 2 circles, 2 integrations, and 1 parabola. If you're able to do these things, then you can get your marks. Is it clear? Right. So tomorrow we'll continue with those things. And once again, I'm repeating, start your preparation for with circles long answers, and compulsory 2 circles, 2 indefinite integrals, total 4 long answers you have to do from these 2 chapters. So better you go for more number of questions. Yeah, people are telling nowadays important questions, but last 2-3 years in 2B especially is not giving any important. All different questions he is trying. So last in March also it did the same thing. In integrations, people used to study very important long answers. He has not given one also. 2 different long answers has been given. In circles also, long answer it has changed. So what I'm saying is, only important you don't depend on that. Okay. So little bit more number of questions you are going to prepare for your exam. That should be on safe side. Okay. Okay, then tomorrow we'll continue with same differential equations. After that, in hyperbole ellipse, few 4 marks already done, but little bit more few 4 marks. So those who want to get good marks and those who failed and want to pass, as I said beginning of the class, circles and integrations and parabola. That's all. These 3 you can do perfectly so that you can get your marks. Okay.